First thing we need is words, but they can't be any old words, they need to be Wordle words. Now Wordle will let you pick from 13,000 words, however, when picking the answers, there's only actually 2,315 words that they pick from. This is because of the secret rules that are used when the New York Times are picking answers. They can't be proper nouns, so no people names or place names. They can't be plurals that end in an S, and they must be common words. With those words downloaded, we can access them with a Python script, and from there we can build our engine around it. The first thing I want to do is build an algorithm that determines the value of each word. A word's value will be determined by how common the letters inside it are among the rest of the words that we can choose from. The way we do this is by looping over every single letter in every single word and keeping a record of how many times we see each letter in a key value pair or a dictionary. The way to do this is by iterating over all the letters, and if the letter has already got a record, then you just increase its number by 1, otherwise you create the record and set it to 1, because that's the first time we've seen it. After a quick correction to the syntax, we're ready to go. And now that that's working, we have a score for every letter. So we can turn that into a function, and I also want to make another function that will score a letter based on its position in a word. Doing this means that our guesses are much more likely to get green letters instead of yellow letters. And at the very least, if we do get a yellow letter, it will knock out a big chunk of words. Building this function is very similar to the previous one, only we have an added dimension to the key value pair to describe the position that the letter is in. A couple of minor adjustments to the logic, and once again, we're good to go. Now that we've built the algorithms for deciding the value of each letter, we need to build an algorithm that uses this to determine the value of each word. This is actually the simplest one yet. We just iterate over each letter within the word, get its values, and add them together. We've outputted the score for the word audio, it's 3,882. And now that we have a way of scoring words, we need to find the best word. So the way we're going to do that is by iterating over all of the available words, scoring them against each other, and then picking the one with the highest score at the end of that. Specifically, it's going to iterate over every single word and keep a note of the high score. If a word comes along that beats the high score, that word will go down as the best word until another word appears that has an even higher score. Once all the words have been iterated over, whichever word currently holds the spot as the best word wins the competition. Well, I was rather taken aback by the result of that. But in all seriousness, that's a terrible word, and we need to figure out exactly why on earth our algorithm decided it was the best. I reckon it's because A is one of the highest scoring letters, and it has 2 of them. I decided the way to fix this would be by having it only score each letter once in a word. That way, if a letter appears twice, it will still only be scored the one time. Not only does this take away the incentive of putting high value letters in more than once, but actually it punishes words that have the same letter twice. Positional scores though, they stay the same. After throwing my keyboard against the wall, I realised that the issue is that the algorithm was crashing on a number of words, and so loads of words weren't even being counted. Turned out all it was is I was feeding the positional scores into the base score algorithm.
Nice.
So now that we have all the algorithms in place for determining the best word, we now need to build a simulation around that so that we can test it. The first step for doing that is creating a function that will compare a guess to what the actual answer is. In Python, the way we're doing this is by, instead of returning grey, yellow or green squares, we're returning 0s, 1s and 2s in an array. Coding this is pretty straightforward, but there are a number of edge cases that we need to consider. For example, making sure to only show one letter as either green or yellow if the user has guessed 2 of the same letter in a word. Doing this was pretty straightforward. I just rewrote the function and included a key value pair to keep track of the amount of letters in each word and how many letters could be highlighted at once. Next on the to-do list is to use this feedback to remove any invalid words from the remaining word list. First thing we've got to do to achieve this is filter out any words that don't meet some minimum requirements. So for example, if we know that the word has at least one A in it, then we need to get rid of any word that doesn't have any A's. Also, if we know where a letter goes exactly, then we can get rid of any word that doesn't have that exact letter in that exact spot. Similarly, if we also know that a word can only have at most a certain amount of A's, then we can get rid of any word that has more than that amount of A's. And by just applying these little validation filters, we can basically choose which words we keep and discard. With the new word list being generated, we can feed them forward into new guesses and simulate an entire Wordle game. After adding some basic reporting and tracking to the bot performance and a little bit of debugging, looks like we're ready to go. It was able to get Zebra on its 4th go, which is pretty good. And even though it has a Q in it, it got Quite on its 2nd go. But to fully understand its ability, we need data. To get data, I'm basically feeding every single possible answer into it, and we're going to run it through a simulation, and we're going to get the average amount of guesses that it takes to succeed, as well as the overall success rate.
A few moments later.